Hey there, y'all. We're going to look today at 5.2 on the solutions of linear inequalities. We looked yesterday at 5.1 on being able to graph linear inequalities, and we're going to review that a little bit today. But today we're going to focus on what ordered pairs are a solution of these problems. And so our objective is to be able to determine if an ordered pair is a solution of that linear inequality, and it's still falling under the standard of being able to graph these solutions. And so let's take a look at these first two examples here. These are kind of mirrored examples. So we're going to first determine if this ordered pair is a solution of this inequality. And so we need to plug in this ordered pair. So remember, ordered pairs are always in the form x comma y. And so we're going to substitute that into this inequality and see, does it work or not? That's all we have to do. And then we'll determine if it is a solution or if it's not a solution. Now, if this was an equation, we want to make sure that the left side equals the right. But this is an inequality, so we just need to make sure that it matches the inequality that we have. And so when I substitute this in, I'm going to get negative 4 is with the y, greater than or equal to 1/2 times the 4 minus 5. Now, if I do negative 4 greater than or equal to, what is half of 4? That's 2. 2 minus 5 is negative 3. Is negative 4 greater than or equal to negative 3? Yes or no? The answer there is no. So the ordered pair for negative 4 is not a solution of this inequality because it does not give us an answer that makes logical sense. Negative 4 is not greater than or equal to negative 3. Let's see what happens on example 2. Different ordered pair, same inequality. So now I'm going to substitute this in. Remember, x and y, right? So 1, is that greater than or equal to 1/2 times the 4 minus 5? Well, 1 greater than or equal to, half of 4 is 2 again, minus the 5. And is 1 greater than or equal to negative 3? A positive number will always be greater than a negative, so this checks out. So yes, it is a solution. It's just as easy as that to check these answers. Again, we just need to verify if the result makes logical sense. Does the statement make sense as we read it from left to right? Okay. Now, in examples 3 and 4, we're going to test a few ordered pairs and see if they are solutions to this graphed inequality. Now, you'll recall back to yesterday when we looked at graphing these up. We talked about how the shaded region is where all of our solutions will be, and also any points that lie along a solid line. If they lie along a dashed line, they are not solutions. But again, if they're in the shaded region, they'd be fine, right? So let's look first at example 3. And I'm going to just plot these points on the graph so we can see where they're at. So point 2, 3, 2, 3 is right here. Is that point either on a solid line or in the shaded region? Well, it's definitely in my shaded region, so the ordered pair 2, 3 is yes, it is a solution. My next point is 0, 0. 0, 0 is right here. It's really close to that red line, but it is not on the line. So 0, 0 is not a solution to this graphed inequality. And finally, let's look at the ordered pair negative 5, negative 2. Negative 5, negative 2 is way over here, and it is clearly not in the shaded region, so negative 5, negative 2 is also not a solution. We look at every individual ordered pair based on where it is in the coordinate plane and where it is based in either the shaded region or the non-shaded region or on the line. Now, we'll do example 4, and then I'm going to talk about the questions that are at the bottom of both these questions. So let's look at example 4. Determine if the following ordered pairs are a solution of the graph below. And again, we'll plot these points up and see where they belong. So 2, 4 is right here on the dashed line. And remember what we said, a point that is on a dashed line is not a solution of this inequality. The line must be solid for it to be a solution. Let's look at the order pair 0, 0. 0, 0 again is not in the shaded region of this picture, so 0, 0 is not a solution because again it's not in our shaded region, it's in the white region, right? Last order pair, we're looking at -6, -1. So -6, -1 is way out here, and it is in our red shaded region, so 6, 1 is yes. It is a solution. Now, we look at these two problems. We see that 1 was yes and 2 was no. That's just coincidence. All three could be yes. All three could be no. It could be any combination thereof. If you have more order pairs or less order pairs, it all just depends on what you're given. Okay? Now, let's look at the two questions that are below these two graphs. And that question is this. What is the linear inequality for each of these graphs? And so that goes back to what we did in section 1 with understanding graphing these. Now we're going the opposite direction. We're having to pull out the inequality from this graph. And so to do that, we need to do one of two things. We either need to do it in slope-intercept form, because if I can find the slope and find the intercept, we will plug it into that very quickly. If I can't tell what the y-intercept is, then of course I could use point slope form. And remember that that is y minus y sub 1 equals m times x minus x sub 1. So let's look at example 3 here. Can I tell what my y-intercept is? Yeah, it's right here. It's at -1. So my b is equal to -1. What's my slope? Where do I go? Well, I need to find a point that is on the line and I can tell very easily. Well, this point at 1, 2. So I'm going to go up how far? I'm going up 3, right 1. So my slope is 3 over 1, which is just 3. And so what is my linear inequality? I'm going to have the y, and then I'm going to have 3x minus 1, the 3 from the slope, that's our m, and the b, the -1, being the y-intercept. Now, I haven't filled in the inequality yet, and that's going to be the last part of this. What inequality symbol is going to go here? Well, my line is solid, so it has to be equal to, so I'm going to have that equal to bar on the bottom. If the line was dashed like it is in number 4, then I'm not going to have the equal to bar. But I've still got to determine which way the shading goes. And here's how you can test it. If you're in slope-intercept form, or if you're in point slope form, this is the quickest way to get it. Go to your y-intercept. Where am I shaded? Am I shaded above the line or below the line? In this case, y, my y-intercept, the shading's below the line, so y is going to be less than or equal to 3x minus 1. Now, this only works for problems where the y is either alone on the left-hand side or you have the constant like you do in point slope form. Now, let's look at example 4. Last thing we're going to look at. So again, if it's nice and easy, we'll use slope-intercept form. If I can't tell that intercept very well, then we'll use point slope form. So again, I look at this graph and I can see that the y-intercept, the b, is equal to +1 in this case. And I look for my next point that I can get, and it's actually this black point here that we had before, which was 2, 3. And so how far do I rise and how far do I run? Well, I'm going to rise 3 and run 2. So my slope is 3/2. And so I get the y, I get the 3/2 x plus 1. And then we have to ask ourselves, what type of inequality will go here? Well, my line is dashed, so it's not equal to. I will not put the bar on the bottom here this time. Where's my shading? Is it above the line or below the line? Well, when I look at this y-intercept, the shading is above the line, and so y has to be greater than 3/2 x plus 1. And we could test some order pairs here. We can test like the -6, -1, and plug that in and see that it would give us a true statement. And if we plugged in 0, 0, 0, and 0. So I get 0 is greater than 1. Does that make sense? No, 0 is not greater than 1. So that's what we've got. And so that's the lesson for today. Like I said in the announcement video, the majority of the problems that you'll have will be dealing with what you've just seen here. The last few problems will be a little bit of review from what we did in section 1 yesterday. Again, if you got questions, hit up that email or hit up that Google Meet or Google Chat, and I will catch y'all next time.